Okay, good afternoon, everyone. Good afternoon, everyone. So we are starting this chapter called gravitation, right? So before starting this chapter, let me ask you some questions, right? Because we have already studied about this chapter in class 9th. If you remember, we have already studied what is gravitation in class 9th. Okay, so I'm just taking from the very basic, and I'm expecting that all of you know what is G, small g, right? Tell me, what is small g?
Acceleration
Anyone?
due to gravity.
Yes, it is acceleration due to gravity. Okay, very good. And what is capital G? What is capital G? Anyone? Yeah. Yes, gravitational constant. Very good. So at least you know the difference between small g and capital G. Okay, so that's okay. Very good. Now let's start this chapter. Now, when we talk about this chapter, gravitation, when we this talk about this chapter, gravitation, okay, first thing that pops up in your mind is what is gravitation? Okay, what is gravitation? Tell me, what is gravitation? It is a physical phenomena, yes. What else? Or I'll be very specific, yes, it is a kind of force. Okay, now when we talk about forces, let's see, when we talk about universal forces, okay, we have mainly three type of forces, What is the meaning of universal forces? So I'm just talking about universal forces. Okay, my handwriting is very bad. Universal forces. Okay, so by universal forces, yes, very good, Avas, right? So we have first gravitational force, second is electromagnetic, and third is nuclear. Okay, so these three are your universal forces. Okay, now when we talk about gravitational force and electromagnetic force, so electromagnetic force is further divided into two types. Okay, it is further divided into two types. One is electrostatic force, and magnetic force. Right, everyone? Okay. Now, before starting this, right, let's understand the concept. Okay, the concept of a term called as field. Right? Now tell me, what is the meaning of field? Just think about it. What do you mean by field? Tell me, area, space, right? A playground or a classroom, right? Okay. Now, what is the meaning of this field in case of physics? Okay. What is the meaning of this field in case of physics, right? That is, yes, very good, Siddharth. Very good, everyone. Very good, right? So, as I say, field in terms of physics can be said as region or area or space, right? Region, right? Or area or space, okay, up to which, up to which anything, anything has its effect, has its effect. As simple as that, right, everyone? For example, just think about a scenario. Suppose a class, suppose consider the scenario. I'm teaching in your classroom, right? I'm teaching in your classroom. Okay, in one classroom, which is suppose any room number of your JVM school. Now, do you think that Can you hear me, or can principal sir will hear me from his office? No, right? So can I say that the classroom which I'm teaching, the classroom in which I'm teaching is my field, right? Is my field of class, right? Because you only can hear me. Or just think about your room. Okay, suppose you turn on your AC, okay, in your room. Now, do you think that you will feel cold outside your room? No, right? Inside the room itself, right? So I can say that there is this region, okay, this region which is under observation, or under which, right, in which anything, we will talk about what are those things, have its effect. Now this field are of two types, okay, this field are of two types. Tell me, what are these two fields? Anyone? Anyone? When you talk about physics, physical quantities are generally of two types. Yes or no? Physical quantities are generally of two types. What are they? Everyone know this. Everyone know this. No, Ria. Basic. Vector and scalar, right? Vector and scalar. Very good. Very good, Shurika. Very good, Shrihari. Very good. Wes, right? Vector and scalar. So obviously this field is associated with your physical quantities. Yes, so it can also be of two types, scalar field and vector field. Agree? Tell me, agree? Okay, now you should ask, so what is the meaning? What is the meaning? So I'll say it is simple. What is scalar? Scalar means only the magnitude changes. Direction does not have any effect, right? And what is vector? Both direction as well as magnitude will change, right? Or will be considered. Now, if you think about the temperature in the room, when you turn on the AC, like obviously after some time, I'm not saying that as soon as you turn on your AC, but after some time, right? Don't you think that the room will be evenly cooled? Think about it. It will be evenly cooled. Yes, doesn't matter where you sit, right? You will feel the coldness, right, evenly. So don't you think that this temperature field, right, temperature field, because of AC will be scalar? Yes. Yes, very good. It won't be like 30° I cap or 30° J cap. So this temperature field due to AC is your example of scalar field, right? Now think about gravitation. Think about gravitation. Now when you talk about gravitation, right? All the object, when you drop it, right? It follows a straight path. It follows down, right? It drops down. Yes. So there's a direction. Okay, this direction which is always toward the earth. So I can say that this gravitational field is a vector field, right everyone? Right? Okay. Okay, very good. Now this vector field itself is of two type. This vector field is itself of two type. What are that? What are those? I hope all of you have already heard. Conservative and non-conservative. So I guess all of you have heard of conservative forces and non-conservative forces, right? No, vector, this is about vector. Gravitational is just example, right? Gravitation is just example, okay? Right, this is about vector. I'm just rub this. Okay, Yes. So in conservative, we have gravitational. Gravitational. Okay. Electrostatic or electric field, right? And in non-conservational, we have magnetic field. Okay. Now, why I'm teaching you this? Why I'm telling you this? Because if you see this, gravitational and electrostatic, right? Gravitational and electric fields, okay, or electric or gravitational forces, both are conservative, both are vector fields, right? Got it? Got it? Tell me, think about it. Yes. So you can assume that both will have almost same characteristics. Okay, right? So when we will be studying gravitational field, you will complete half of the electric field. Okay, because it will be same, right? Now let's come to gravitational force. Now, actually, can you derive this gravitational force? Tell me. We know that gravitational force. I need not to teach who discovered these things, right? Because I guess all of you already know this. Okay. Yes. So it was discovered by Newton. Obviously, so Newton have discovered this, and he said that this force is inverse. It follows inverse square law, right? It follows inverse square law. So he said that this is the observation that he did, that the force due to gravity, right, is directly proportional to mass, right, or product of mass, right? Because when you talk about forces, okay, it will always be between two objects. Can you say that, okay, we have an object m1, and it is experiencing a force? Think about it. If there's nothing else, can you say that this object m1 is experiencing a force? Is it a true statement? No, right? Because if you say, okay, this is experience a force, the second question would be, because of what, right? Or just imagine someone saying you this, right? That someone is pushing me, okay, but there should be someone, right, to apply the force, right? Got it? So we always have a system of two or more object, okay? System of two or more object, right? Okay. Now, so if we have two objects of mass m1 and m2, I can say that according to Newton, the force between them, the gravitational force between them, is directly proportional to their masses. Okay, obviously if the heavier the object, more will be the force. And the second thing that he said was it is inversely proportional to square of the distance between them. Right? Makes sense? Makes sense, guys? Because if two objects will be far apart, right, the force will be less. Okay, so if you club these two, we said that the force, right, the force is directly proportional to m1, m2 by r square. Karishma, screen is visible, everyone? Screen is visible, right? You can just leave and then join again, okay, because screen is visible. Okay, now, since this is a proportionality, right, this is a proportionality, we have to have a constant to remove this proportionality, and that constant is called as capital G. That's why I asked you, what is the difference between capital G and small g? This capital G is the proportionality constant, right? So we have formula G m1 m2 by r square, right? Okay, right, everyone? Where the value of G is, tell me, what is the value of G? 6 point, Abhiram, tell me, 6.67 into, tell me. I hope all of you remember this, 6.67 into, yes, very good, 10 to the minus 11, very good, Karishma. Minus, right? Minus 11. Okay, got it? Now, what do you think? What do you think? This is just the magnitude, right? This is just the magnitude of the force between two objects, right? What about direction? Tell me, what about direction? Because obviously this is a vector field, right? The force, this force, right, is a vector because force is always a vector. Okay, so there should be some direction. Okay, so I can say that magnitude wise the gravitational force is given by G m1 m2 by r square, r square. So we have this object m1 and this other object m2, and the distance between them, the distance between their centers, okay, the distance between their centers, right, is your r. Then it is your formula. Now this is called as scalar representation. Scalar representation, right? Because this expression does not give me any idea about the direction, right, everyone? Okay. Now, what if I want to write the vector representation of the force, right? So this is the magnitude. We know that any vector, suppose this is vector, it can be written as its magnitude, right, into direction. So I'll just write direction as r cap. Okay, agree? Tell me, agree? Or is there any mistake in this? Tell me, is there any mistake in this? Yes, I said r cap, but I wrote r arrow. Okay, because if this is direction, it should be your unit vector, right? So this is r cap. Okay, and what is this r? This is this distance. So I'm saying at r12. Okay, because obviously if it is a distance, it should have one start point and one end point. So this is r12. Now if I'm saying r12, then this force will become F12. Agree? So what's the meaning of F12? Tell me. The meaning of F12 is force on object 1, force on object 1 due to object 2. Right? Right, everyone? Got it? Right? Easy? So think about it. Think about it. I'll just rewrite it. F12 is equal to, this magnitude is G m1 m2 by magnitude, see, magnitude of r12 whole square into r12 cap. Can I write it as like this? R12 cap is r12 vector by mod of r12. Yes or no? Yes or no? Think about it. Because this is a unit vector, right? I can write unit vector as vector divided by its magnitude. So if you see this, it will become like this: G m1 m2 into r vector, right? This is vector divided by mod of r12 whole cube, right? So somewhere you can get this formula. Okay, so do not get confused, right? Because this is still inverse square law. Okay, because r vector divided by magnitude of r, it is just a unit vector. Unit vector. Got it, everyone? Got it? And I assume that every one of you know vectors. If anyone who doesn't know vector, please let me know. I'll explain. Okay, because I'm assuming that all of you have solved all the chapters and you know vectors. Need students? Tell me, vectors, everyone clear? Okay, very good. Now, what do you think? If F12 is this, what would be the expression of F21? Tell me, what's the meaning of F21 and what will be the expression of F21?
Force on 2 by 1.
Yes, right. So this will be G again, M1, M2 by R21 whole square into R21 unit vector. And we know that R12 unit vector is negative of R21 unit vector. Agree? Right? So can I say that? Can I say that this is nothing but negative of F12, right? Anyone have any doubt till this point? Tell me, anyone have any doubt till this point? No? Clear? Okay. Okay. My second question is, what would be the nature of this force? Tell me, what would be the nature of this force? Attractive, repulsive, both? Think about it. Attractive, right? It is always attractive. So I can say that gravitational force is always attractive, always attractive, right everyone? Because we have only positive mass, we don't take negative mass, right everyone? Okay, we will never take negative mass, at least till in our syllabus. Okay, we will always take positive mass. So the product of masses will always be positive. Okay, so that's why gravitational force will always be attractive. But if I talk about electric force, think about it. Electric force will be due to charges, yes or no? Think about it, right? It will be due to charges. Okay, and what would be the nature of charges? We have two types of charges, positive and negative, right? So obviously the force between the charges can be both attractive as well as repulsive, right everyone? Tell me, right? And what about magnetic force? What about magnetic force? The same thing. We have North Pole and South Pole, or again different charges. So it will also be same as electric force. Okay, so I'm just giving a hint how we will relate. Okay, electric field with gravitational field. Now, as we know that this force is a vector whose formula magnitude is given and direction is again a position vector. So just consider what we have studied in chapter 4. Okay, right? That's it. Whatever we have studied in chapter 4, we will be using this. Now suppose we have this point is 2,5, right? And a force is applied, F, whose magnitude is F, right? So what will be the representation of this force vector? Tell me. Magnitude is F. Then tell me, what will be the representation of this vector? Tell me everyone. Magnitude is given, that magnitude is F. See, that's the thing, right? That's the thing. Because this is the mistake that you guys do. Okay, it is F into. Now this should be R cap, right everyone? Think about it. This should be R cap, right? Yes or no? Yes or no? But if you're writing 2I cap plus 5J cap, is it R cap or is it R vector? Tell me. Think about it. Now you're getting my point. Why I asked this very basic question? Okay. So this is the mistake that you guys did. Some of you did. It is magnitude of F, right, into R cap, which is 2I cap plus 5J cap divided by root of, tell me, 29. Okay. Okay, everyone. Got it? So this is one mistake that students tend to do. Okay. Right. So please don't repeat this mistake. I just said, Sneha, that when we talk about force, when I talked about force F, I said that the vector form is magnitude, which is basic formula, and then position vector, as simple as that, right? Or distance vector, right? Okay, now here I'm saying that we have one object at this point and one object at this point. Magnitude of force is given, which is mod of F. I want to write this force in vector form. Okay, so I should write magnitude into r cap. R cap, right? It should be unit vector because I just want to know the direction. I don't want to know the position. Okay, I just want to know the direction because we have magnitude. Okay, right, everyone? So I hope all of you can solve formula putting getting one, right? Find the force if mass is given, distance is given. So I'm not doing those things, okay? Because you can do that, right? So the next topic after this, the next topic, okay, is called as superposition of forces. Now, this is something that you have already studied. Okay, this is something we have already studied in chapter 4, I guess, Newton's law of motion. Now, what do you mean by superposition? Tell me, everyone, what do you mean by superposition? That's just a fancy term for a simple term. That simple term is addition. Okay. Now, tell me, did you add any force in chapter 4, right? What you did, you added forces, right? Yes or no? Right? You added forces, especially in vectors. When we had different forces acting on an object, you added them. Okay? Using, yes, net force. Agree? Yep. You did that, right? Okay. Now, suppose we have three particles. Suppose we have this as M1, this as M2, and this as M3. Okay, I'm just taking three. Now, if I'm asking what is the force on M3, what is the force on M3, right? Okay, I'm not talking about, okay, F on M3. What do you think? What it will be? Tell me, everyone. Think about it. I'm not talking about the formula, right? Tell me, it will be because of just M1 or M2 or both. Yes, very good, everyone. So I can say that Fm3 should be force on 3 due to 1 plus force on 3 due to 2. Agree? Agree, everyone? Anyone have any issue in this? Tell me. Seems simple, right? Seems simple. That's it. That is the superposition of forces. As simple as that. Okay. That is the thing. Okay, that's why physics is very simple if you try to imagine it. Okay, now suppose I want to write the formula because again expression is easy, but what if when you have to write the formula? Now think about it. Suppose this distance is r1 and this distance is r2. Okay, right, everyone? Right? Now tell me, now what would be the expression? What would be the expression? So F on 3, I'll just write F on 3 will be, now the best thing to do, right? The best thing to do is find F31 separately. Okay, right? Find F31 separately. What is F31? G, tell me, M1, M3 divided by mod of R2 squared into R2 cap. Agree? Tell me, guys. Yes? Right? Easy? Okay. And F32 in the same way is G M2 M3 by R1 square, because this I have given as R1. This is just a variable. Okay, this is just a variable into R1 cap. Any issues till this point? Any issues? See, Jasharan, okay, I will be using square if I'm using R cap. Okay, if I'm using R vector, then it will be cube. Okay, right? Please consider this. Okay. Now, so can I just write it? I'll just write it like this: G M1 M3 by R2. This is R2, right? This is just a variable square into R2 cap plus G M3 M2 by R1 square into R1 cap, right? That is the expression, yes or no, right? Simple. If you break down your topic, it will be simple, like simpler, right? Now, this is the system. This is the system of three objects. In the same way, if I want to find the force on F1, right, it will be what? It will be F1 due to 3 plus F1 due to 2, right? Force on F2 will be force on 2 due to 1 plus force on 2 due to 3. Agree, everyone? Right? You can find it in the same way. Okay, now let's generalize this. So what does superposition principle says? Okay, suppose I'm having n objects, right? Or n system of particle, right? N particles or n object having different masses. Okay, right? So I'll just take like this. Okay, right? We have n objects. I want to find, so suppose this is, I'm not writing it, I'm just writing it as object O. Object O. I want to find the force on object O. I want to find net force on object O. Okay, so this will be the force due to all the objects. Okay, this will be the force due to all the objects. Make sense? Right, everyone? Make sense? So this will be what? This will be F on O due to 1 plus F on O due to 2 plus F on O due to 3 dot 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 F on O due to N. Okay, simple concept, right? Till here, no issues. But obviously, as physical chemistry, okay, in physics also, concept wise, if you know the concept, it's first stage. Second stage is calculation. Okay, now let's see one problem. Right? Now let us have a problem. This is your equilateral triangle. Suppose we have equilateral triangle. Okay, an equilateral triangle, and the distance is suppose 2 centimeter, right? Suppose 2 centimeter. This mass, this is M1, this is M2, and this is M3. M1 I'm giving as 1 kg, M2 I'm saying as 2 kg, and M3 I'm saying as 5 kg. Okay, right, everyone? This is information. Yes, that is applicable for particles because we are adding, right, somewhat, right? But if you talk about this continuous object, so what is the equivalent mathematical operator for continuous addition? Tell me. We will do that also. We will no integration, na, right? Integration. Because when you talk about sum, when you talk about addition is for discrete particle. That's what we have done. But when it is continuous particle, we will do integration. We will do the same thing, right? We will solve one problem based on that also, right? And I hope everyone know basic integration, formula putting and getting. Everyone know that, right? Basic integration. Need students? Okay, right? Now suppose I want to find force on third object. Tell me what is the answer, right? Tell me the answer in terms of G only. Okay, yes, using vector Maulik because it's a vector quantity now, right? That's the thing. Okay, find force on 3, right? Find force on 3 and you have to use vector. Okay, very basic. Think about it. I hope some of you remember. I don't know if I taught to you guys in foundation or someone else, but I have taught this in foundation. Abhiram, do you remember? Shrihari, Neet, Jasharan, anyone? Aryan? Sneha, the question is find the force on third particle, F3, third particle, right? Do you have any object on the center? Think about it now. Before asking, before solving, think yourself. Ask yourself, is there any particle at the center? Is there any particle at the center? No, right? So if there's no particle at the center, right, you will find force of what? Due to what? On what? Right? Okay. So you have to find the force on the third M3, right? This M3. Okay, total force on M3. Think about it and do step by step. Okay, step by step. Now this is a more of a problem of vector. Okay, so this chapter will be using vectors a lot. Okay, that's why I asked that how many of you know vectors? That's something you have to find, Karishma, right? That's something you have to find. Okay, right? Using vectors. So I'll tell you, I'll solve one problem. Okay, I'll solve this problem. The first thing that you have to know, make a coordinate system. Now make a coordinate system, right? So let us make this as a coordinate system. Let us make this as a coordinate system. Okay. Wait, pardon my. Right, this as a coordinate system. Okay, right? Because obviously when you're talking about vectors, there should be a coordinate system. Yes or no? Right? Yes or no? Tell me, guys. Now, we know that this is 2 centimeter. The length is given. The length is given. Step by step. This is the first step. Length is given. And this angle we know. This angle is, tell me, 60 degree. So what you have to do, resolution of vector. I hope everyone remember, right? I hope everyone remember. Okay, so you have to find F3. So F3 is what? Tell me, F3 is what? F3 is equal to F3 due to 1 plus F3 due to 2, right? Now, break it down, break it down. Okay, break this down. I'll just write over here. What are the forces that we require? Okay. Now think about it. When you talk about this object M3, due to M1, forces in this direction, yes or no? Forces in this direction, agree? This is the direction of force. Yes, right? Agree? So this is the direction of force. F3, 1. Yes or no? Tell me, guys. Yes or no? Step by step. Yes or no? Because it is attractive force. So when we talk about this, right? Okay. The arrow sign is correct or wrong? Tell me. The arrow sign is correct or wrong? I'm deliberately making those mistakes which you guys will make. Okay. Now this is wrong. Okay. This is wrong. Why this is wrong? Think about it. Why this is wrong? Because see, Concepts are easy, but there are very small mistakes that you guys will repeat. As I said, gravitational force is always attractive. Yes or no? Think about it. Gravitational field is always attractive. Now, if M1 is attracting M3, the force direction would be this direction or opposite direction? Tell me. Toward M1, very good. So the direction of force is actually in this direction because it is attractive, right everyone? So that is the first mistake that you guys should not do. Okay, so this is this direction. Okay, this is actually force on 3 due to 1. Okay, got it everyone? Tell me, got this? Right? Got this? Yes? Okay, very good. Now, what is the direction? What is the direction of force on M3 due to M1? Sorry, M2. It's in this direction, right? I'll just use green pen. In this direction, yes or no? Yes or no? Right? Very good, everyone. And this angle is what? 60 degree. This angle is 60 degree. So this is my force equation. Sorry, this is my force diagram. Yes, this is my force diagram. Same as free body diagram. Yes or no? Same as free body diagram. And it's actually a free body diagram, right? That we have already studied in chapter 4. Now, what we have to do after this? Tell me, what we have to do after this? Anyone remember? Tell me. Resolution of vector. Yes, everyone. Resolution. Those who have studied foundation, they will realize, right? They will realize that why I said that resolution of vector is very important in class 11th. Okay, we will use resolution of vector. Okay, we will not use see, because we have only no issues, Abhiram, you will get the correct answer. No, doesn't matter, right? It doesn't matter. Okay, right? Because vector can be shifted. Now vector can be shifted, right? Even if you take this as origin, still the force will be this direction only, no? Right? Doesn't matter where you take the origin. Force diagram will be this only, always. Yes or no? Tell me. Even if you take M1 as origin, still force diagram will be like this. Okay? Okay. So can I say that? Can I say that? Just think about it. F31 is what? This is 60 degree. It will be magnitude of F31. Magnitude of F31. I'll just write magnitude as F. Okay. I'll just write magnitude F31. Okay. Magnitude. Now, cos theta, agree? Cos theta, right? Now, what is the mistake over here? Tell me, what is the mistake over here? There's no mistake. I should write minus I cap. Right, everyone? I should write minus I cap. Yes or no? Because it is your second quadrant. And in second quadrant, x component is negative. Right? If I'm taking this angle. Okay? Plus F31 into sine theta. Right? If I'm taking this theta. Right? If I'm taking this theta. So it will be plus j cap. Got it? Tell me. Got it? Everyone, step by step. Mansi, Sumaya is absent or present? Sumaya is okay. She is traveling. Smurti, Samya, Sanya, everyone is getting. I'm using the concept which we have already studied in chapter 3 and chapter 4, right? Resolution of vector. Okay, right? So I'll just write it. F31 is equal to, I'm just writing as F. Okay, I'm just writing as F cos 60 degree, cos 60 degree minus I cap plus F sine 60 degree j cap. ठीक है? Got it? Right? Okay. I just resolved this, right? I just broke this force into x component, y component. Okay, Karishma? I just broke it into x component, y component. Now, since it is in second quadrant, x component is negative, so minus I. This is I, okay? Right? I hope all of you are acquainted with my handwriting. Okay. Now, what is F32? Think about it. F32 is just on x-axis. This is just F into minus I cap. F32 into minus I cap. Agree? Got it? Right? Anyone have any issue in this? Now, why I am breaking down in components? Because it is easy to add vectors in their component form. I hope all of you remember this from vectors, that it is easy to add the vectors in their component form. You can just add x and x, y and y, right? That's why always, whenever you deal with force, always break it to components, okay? Okay, so total net F3 is equal to, now this F and this F will not be equal, right? Okay, so I will write, okay, wait, I will further simplify this, okay? Now magnitude of F31 is equal to what? Capital G M1 M3 by mod of R31 square. Agree? Yes or no? Agree? Which is equal to G. What is M1? What is M1? M1 is 1 into, what is M2? M2 is 2 divided by, what is R? R is 2, right? 2, but it is in centimeter, right? So if you want to convert into meter, don't worry, you can convert, right? It should be converted into meter, right? Okay, it should always be converted into meter. So into 10 to the minus 2 whole square. Okay, find this separately, okay? Find this separately, okay? You just put at the last, okay? Just put it at the last. In the same way, F32 is equal to G into M3 is, okay, M3 na, M3 is 5. Yeah, sorry, my bad, M3 is 5. My bad, guys. Yes, M3 is 5. Okay. Which portion, Soumya? I'm just finding the magnitude now. For magnitude, you can just use the formula Gm1 m2 by r square. So F31 is Gm1 m3, right? I made a mistake. Okay, right? Got it, Soumya? Yes or no? Because magnitude you just find separately and put it in the formula at last. Okay, put it in the formula at last. Okay, got it, Soumya? Okay, Samarth, got it? So it is M3 M2 by R32 square. Okay, find it in same way. So G into 2 into 3, sorry, into 5. Thereby this 2 into 10 to the minus 2 R square. Okay, right? Right, everyone? Step by step, right? Now, I'll just write the final answer. F3 net is equal to F31, which is F, I'm writing it as F, I'll write this as F dash, okay? F or minus F cos 60 degree I cap plus F sine 60 degree J cap, now plus this, plus F dash minus I cap, okay? So this will be what? This will be, tell me, minus F cos 60 degree plus F dash I cap plus F sine 60 degree J cap. Got it? Now here I'm putting the formula. Okay. So minus F is G. Tell me F m1 m3 by r, because r is same, so I'll just write r square cos 60, which is 1 by 2 cos 60 now, 1 by 2 1 by 2 plus this is g m2 m3 by r square I cap plus, now this is f, which is again g m1 m3 by r square into sine 60, which is √3 by 2 j cap. Got it? Tell me, got it? Now either you can just simplify this here, right, and put it here, or you can just take common. You can take whatever is common. So if you see, we have g m3 by r square common. Yes or no? Tell me. G m3 by r square is common every throughout. So it will be minus m1 by 2 plus m2 I cap plus √3 by 2 m1 j cap. I haven't put the value. It is just the formula, right? Put the value, you will get the answer. Yes or no? Tell me, guys. Yes or no? Did you lost anywhere? Did you lost anywhere? Step by step, right? I tried to explain. Okay, this thing you should have already studied in chapter 4. Okay, so I just assume that you know. Okay, yes, got it. Shall we solve one more problem? Karishma, Mansi, Spurti, Chulika, Samya. Samya, are you getting? Tulip, are you getting? Tell me, any steps which I want to repeat? So you want to repeat? First thing, draw force diagram. Second thing, resolve the vector. Then just formula putting. Okay. Samya, Tulip, Shreya, Imba, Sania, Anjali, Anisha, Namika. Anyone have any doubt? Tell me. Yes or no? Any doubt? No doubt? Okay. Can we solve one more problem? Right? Very good, everyone. Very good. So let's solve one more problem. Okay, let's solve one more problem. Okay. Yes, I'll give you an easier one. Okay, I'll give you an easier one. Now, this time we have a square. Okay, this time we have a square. I don't know, there's something wrong with me. I cannot draw straight line. Okay, we have a square. Assume that this is a square. Okay, so, and the second thing is mass is also same. Mass is also like 1 kg. Okay, for simpler calculation, mass is same. M1, this is 1, this is 2, this is 3, this is 4. Okay, so M1, M2, M3, M4, all are same, 1 kg. For simplicity, okay, 1 kg, 1 kg, 1 kg, right? And this distance is, suppose, again, same, 1 meter, right? Simplicity. Side is 1 meter, okay? Oh yeah, I can use square tool, na? Yeah, better. Okay. Okay. Now R is 1 meter. Can you solve now? Tell me. Find F3. Force on 3. Okay. Right, everyone? Easy. I've given everything 1 1, so calculation will be easier. Find F3. Step by step, guys, step by step. Okay. First, step one, right? Force diagram, force diagram, right? Same as free body diagram. Okay. Step two, resolution of vector. Okay, right? Step three, formula putting getting. Find magnitude of forces. Step 4 is your calculation. Okay, simple 4 steps. Try to follow this. I'm giving you 2 minutes. Okay, everyone. Okay, so this is F2, F due to 2. This is F1, F due to 1, and this is F4, F due to 4. So everyone's check your diagram, check your force diagram. Is it correct? Check your force diagram. Is it correct? Okay, Samarth. So first force diagram, everyone's force diagram should be this. Okay, it's correct, right? Now, second, write down, resolve the first step, done. This is step 1, done. Second, resolve the vectors, right? So we already know F2 is already magnitude of F2 vector is equal to magnitude of F2 into I cap, sorry, J cap. Okay, F4 vector is magnitude of F4 into minus I cap. Okay, and F1 is magnitude of F1 cos 45 degree minus I cap plus magnitude of F1 sin 45 degree J cap. Second step done. Second step, check step by step. Everyone check step by step. So this is correct, everyone. I hope this is correct, right? Okay. Yes. Okay. Third, find the magnitude. Third, find magnitude. So F2 is G, M1, M2, 1, 1, 1 by R. R is 1, 1. So this is just G, just G. F4 is also just G, right? Okay. F1 is also nothing but G because everything is 1, 1 now. So it is G, G, G. F1, F2, F3 all are G, right? Got it? Next, last step, calculation. Okay. See, doesn't matter whatever you take. This is the direction of axis that you will follow, right? Because force is always attractive. So on this object, force will always be this direction due to 4, 1, this direction due to 2, and this direction due to 1. So this is the direction always, doesn't matter what you take. Okay, this will be the correct force diagram, otherwise it will be wrong. Okay, this will be the only force diagram, right? So F net, add it, add everything. So I minus G because of F1 plus G cos 45 is 1 by root 2, G by root 2, I cap plus this again G plus G by root 2 J cap, right? Right, everyone? So the answer is simple. G plus G by root 2 overall, I've taken it as common, minus I cap plus J cap, right? Tell me yes or no. Step by step, guys. Yes or no? Everyone got this concept? Raise your hand. If you got this concept, raise your hand. Riya, Samya, Koshi, Khushi, got the concept? See, last step, I just wrote the formula. F1 is G, na? F1 is G, we calculated F1G, right? F1G. Okay. So, okay, I'll just write one more step. I've skipped one step, so I'll just write that step. Okay. So F net, I'll just write that step also. F3 total is equal to minus F4 plus F1 cos 45 degree I cap plus F2 plus F1 sin 45 degree J cap. Got it? Got it, everyone? Okay, I wrote this also, then just put the formula. Got it? Karishma got it now? Okay, now superposition, all of you understood? Tell me, all of you understood superposition? Yes. Now, the thing is, this is for what? This is for discrete particles, right, everyone? This is for discrete particle. Okay. Now, someone should ask, right, what about continuous particle? What about continuous particle? Okay. Now, let's see. Let's see. Okay, for continuous particle. Now, suppose we have, wait, I'll just draw it. Now, suppose we have a rod, right? This is a rod of mass m. Total mass is capital M. And then we have this again, a mass, point mass of mass. Suppose this is M1 or capital M, and this is small m. Okay, right? Right, everyone? The length of this is capital L. And this distance is given as D. Now think, right? Think, visualize. Force. Can you take, okay, center is this distance, right? So this distance will be D plus L by 2, right? D plus L by 2, capital M. So force is equal to capital G, small m, capital M divided by D plus L by 2 whole square. Can I do this? Tell me, can I do this? Yes or no? Can I do this? Because some of you might think of doing this. Yes or no? Tell me, guys, yes or no? My question is, can I do this? Is this correct? If not, then why? You have to ask, right? Why this is not correct? Because everything in physics can be visualized. Now, think. We know that it is inverse square law. Now, force on this point and force on this point, will it be same? Think about it. Force on this point of the rod, right? This is suppose point, I'll just use green pen, okay? Suppose this is point A and this is point B. Force on point A and point B, will it be same? Will it be same? Yes or no? No, right? Because when you talk about point A, the mass is very less. But when you talk about point B, mass of whole rod is there, right? So obviously, this force is not, yes, the force is not, tell me, constant, right? Force is not constant because mass is changing at every point. Yes, very good, right? So what we have to do? Tell me, what we have to do? Can we use the formula? Can we use the formula of force? Yes or no? Think about the very basic. You should ask very basic questions. First question you should ask, can I use F is equal to G m1 m2 by r square? I'm just talking about the magnitude, okay? I'm not talking about this direction. I'm just talking about magnitude for now, okay? Because direction, again, it is in the direction of D. So it is D cap only, so it doesn't matter. I'm just talking about the magnitude. Can I use this? Yes or no? The first question you should ask yourself, right? Now tell me, can I use this? If I cannot use this, then what? So the answer is yes, I can use this, but there will be some modification. What modification? Now, we cannot calculate the force, okay, as such, because the force is changing. So it is basically infinite particles. It is infinite particles having this distance. Yes or no? Yes or no? So just imagine, I'll just try to explain you, okay? I'll be using this thread. Suppose we have this small line as particles, right? Suppose this small line as particles, okay? And there will be infinite particles like this and having this distance, right? R1, R2, R3, dot, dot, R infinity. Yes or no? Tell me. So I can say that F net will be F1 plus F2 plus F3 plus F4 plus dot, 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 F infinity. Agree, everyone? Agree? Yes or no? Think about it. Yes or no? Yes? And if I ask you, what is the meaning of integration? What is the meaning of integration? It is continuous addition. Yes or no? It is continuous addition, right? Got it? Right? So I can say that, okay, I cannot find this as one unit, but I can take it as a small unit, right? I can take it as a small unit, right? One small unit. Let's take as one small unit. Wait, I have to rub this. Okay. Okay. So let's take one small unit. Okay, instead of taking one bigger unit, let's take one small unit. This unit. Okay, this unit. Like this is very small unit. Okay, and this distance, I'll use a sharper pen. Wait. Okay. Now this distance, tell me, what is this distance? This distance is very small distance, yes or no? This distance is very small distance. Agree, everyone? Right? So a small distance is represented by what? Tell me. Dx or dl, doesn't matter, right? Dx or dl, I'm using dx, you can use dl also. Okay. Okay. Now tell me, what is the total mass of the rod? Tell me, what is the total mass of the rod? Total mass of the rod? Capital M, capital M. What is the total length of the rod? Capital L, right? Now, what is this? This is your linear mass density. Yes or no? It is your linear mass density. Right, guys? which is mass per unit length. Agree everyone? Right? Agree? So this is mass per unit length. So for length dx, what will be mass? Mass dm will be lambda into dx, yes or no? Think about it. So mass dm will be lambda into dx. Some students might have difficulty in understanding this concept, so please focus. Right? Lambda, what is lambda? Lambda here, I'm just saying that it is linear mass density. What is the meaning of linear mass density? It is mass per unit length. Okay, it is mass per unit length. Right, everyone? Tell me yes or no. Think about it, yes or no. It's like suppose you get 100 chocolates in 1,000 rupees. Suppose you get 100 chocolates in 1,000 rupees. Okay, so what's the cost of one chocolate? Tell me, what's the cost of one chocolate? Simple, 1,000 by 100, 10 rupees, right? So in the same way, right, mass of total length L is M. So what is mass per unit length? It is M by L. So this is mass per unit length, right? So what is mass for length dx? What is the mass for length dx? It will be lambda into dx, unitary method. Got it? Right, everyone? So dm is the mass in this distance dx, right? Right, everyone? This is the most important concept that you should know. Okay, this is the most important concept that you should know when you talk about integration, that it is your elementary particle. Okay, everyone got this concept? Tell me, raise your hand. Everyone got this concept? Easy, right? Why this dx? Why this dm? Now tell me, now can I use this formula? Now, can I use this formula now? Yes, now I can use, right? So F will be df is equal to g, m1 is m, okay, small m, and this m2 is your dm divided by distance. Now this section I have taken at which distance? Okay, I'll assume that this whole distance is x. I'll assume that whole distance is x, okay? So this is your x square. Any issue in this? Tell me, any issue in this? Till this point, any issue? Anyone have any issue till this point? If you have issue, please let me know. Everyone is getting? Samya, are you getting? Imba? Jitendra? Preetam is here. Preetam? Priyanka? This is the most important concept. It is not just one question. It is a one concept that we will be using. Okay, we'll be using this concept for everything, right? When you talk about field, okay, you were using right? Field due to ring, field due to lines. We'll be using these concepts. So that's why I'm just hoping that everyone get this concept very well. Pradyumna, Akshaya, Amish, Anga, Chulika, Samya, right? Everyone got this concept? If there's any doubt, please ask, okay? Now what we have to do? What we have to do? Ask yourself, right? Okay, Samya, see. So this is whole length of the rod, right? And we know that we can find the force between two particle only, right? Two particle only. So what I have taken, I have assumed a small section which is very small, right? A small section of this whole rod, and the small section, what will be the length of the small section, right? It will be dx. Yes or no? Tell me. This you understood? Dx. What is dx? Dx is the very small section now. It is so small that it can be considered as a particle, right? Right, everyone? Okay. Yes, only one dimensional. Samarth, okay. Just assume as one dimensional. Okay, it is just length, no breadth. Okay, right? Don't complicate that thing. It will be only one dimension. Okay. for the sake of simplicity, I've just drawn it like this. Otherwise, it's just a line kind of thing. Okay. Now, what is the mass? What is the mass of the small segment? That should be a second question. Okay. What is the mass of the segment? So we know that total mass is capital M. Total length is capital L. Okay. Right. Sneha, this is just a variable, right? Dx is just a variable, na? Tell me, yes or no? You write it as dl, doesn't matter. It's just a variable, right? I can use any variable. Okay, right? X is a variable, na? Because see, if I'm taking this distance as x, that's why I'm taking this as dx. Okay, because this dx, right, is changing. Okay, so I'm taking whole distance as x. Okay, this whole distance is x. So in integration, after this it will be maths. Okay, so just focus on physics portion. Maths portion I'll make understand. Just focus on physics portion. Till this point it is physics. Till this point it is physics. Okay, so first understand physics, then we'll discuss maths. Okay, so this lambda, you understood what is lambda? Everyone, lambda understood what is lambda? Lambda is mass per unit length. Okay, which is your linear mass density. Now, the mass of this small section, right, of length dx is basically lambda into dx, right? Lambda dx. So in this formula, basic formula, now I can say that, okay, dm is the mass, small mass, which is the mass of this small section of the rod. Now, anyone have any issue till this point, till now? Tell me. Samya, are you getting? Ronak, Sneha, Vivek, Tulip, everyone is getting? Now think about it. Think about this. Can we integrate this? Can we integrate this? Yes or no? Can I integrate this? This expression, can I integrate? By the way, sorry, this is, I'll write as M1 and I'll write this as M2, okay? Because you might get confused. This is M1, okay? No, we cannot integrate because this is M2 and this is X. You have to convert this in X term, right? You have to convert it, na? Integration or differentiation happens with the same variable, right? So I can integrate only after converting this. So it will be GM1. Now DM2, it as M2, it is M2, okay? DM2 can be written as lambda dx by x square. Now I can integrate, yes or no? Now I can integrate, right? Because I need this variable now to integrate, okay? Because the mass is changing as the length is changing. So the variable here is length. Yes or no? The variable here is length also, right? Okay. Anyone have any issue till this point? Because from this point onwards, we will be solving it, right? We'll be using maths only. Physics done till this point. Anyone have any issue till this point? Tell me, guys, anyone have any issue till this point? Guys, please respond. Okay, because if you won't respond, I cannot know, right? So integration, we will integrate both sides, integration of df from where to where? 0 to f. Okay. M1 is constant, lambda is constant. So I'll just write it g m1 lambda dx by x square, right? From where to where? Now from where to where? Think about it. X is from where to where? This dx will vary from where to where? From d to d plus l, yes or no? From d, from this point, A point to B point, right? From A point to B point. What is the length of A point? D. And what is the length of B point? L plus D. Yes. So it will be from D to L plus D. Got it? Tell me, got it? Right? Now, if you would have taken L, okay, think about it, right? Okay, Karishma, you can just watch video and ask, right? If you would have taken DL, then integration limit would have changed. Okay, Sneha? Okay. Now you're getting, Sneha, what would have happened if you have taken a DL? right? Then your integration limit would have changed. As simple as that. Nothing else would have changed. And here, instead of x, you should have written x plus something or d plus x, like that, right? So that would be tedious. That's why I have used this whole as x, because calculation wise it will be easier. Okay, now it will be g. Okay, wait, I'll just, yeah. So this is equal to g constant, m1 constant, lambda constant, integration of dx by x square d to capital L plus d. Now tell me, 1 by x square integration, can you do? What is the integration of x to the power minus 2? Tell me. X to the power minus 2 integration. I hope everyone remember x to the power minus 1 by minus 1. Yes or no? Yes or no? Right? Okay, very good, everyone. Very good. So it is, no, it is not A, it is G. My handwriting, it is G. Okay, so it is G m1 lambda. Now this is 1 by x minus d to L plus d, right? And we know that we put upper limit, then lower limit. So G m1, now lambda is again capital M or m2 by L bracket, I just put the value of lambda. Now this is upper limit, which is minus of 1 by L plus d, minus minus plus 1 by d. Okay, if you solve this, what you will get? Minus d plus L plus d divided by d into L plus d, dd cancel, LL cancel, right? So the answer is G m1 m2 by d into L plus d. Got it? Yes or no? Tell me. Yes or no? Tell me, guys. Clear? Everyone clear? Now, if you would have used center of mass, what was the force? It was G m1 m2 by d plus L by 2 whole square. Now, obviously, this is not same. Now, obviously, this is wrong, right, everyone? Right? Okay. So everyone got this? Tell me, everyone got this? Okay, so this is about force. We completed force. Okay, force we completed. Next class we will start gravitational field. So I hope all of you got the feel of this force and what is gravitational force and how to solve it. Tell me, you should feel physics, right? Okay, and see, if you are weak in integration, please practice some problems on integration, because physics, if your maths is strong, your physics will be strong. Okay, if you imagine, and for NEET students, okay, if you don't remember integration, don't worry, just remember the basic formulas, right? Here also we just use basic formula, na, integration of x to the power minus 2, right? We didn't use any hi-fi formula. Okay, 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 everyone. Now just give me honest feedback. Are you satisfied with the class? Just give me honest feedback. Or if you want me to improve something, not foundation students, new students, because if you want me to improve something, I'll do, okay? I've tried to explain in the easiest way possible, right? Okay, very good. Thank you, Vivek. I'll be sending some videos also. Okay, I'll be sending some videos also. Thank you, Ria. Okay, very good. Thank you. Okay, okay, Karishma. Thank you, Karishma. Very good, Akshay. Thank you. Okay, so I'll be sending some videos. Okay, now see, this chapter is very interesting because I don't know, the foundation students might recollect. I have told them that what is gravity actually, okay? Because obviously we study this as a force, right? How many of you remember what I said about gravity? What is gravity? You remember that gravity is nothing but a distortion in space-time continuum, right? Yeah, napkin one. I've done this experiment in classroom, right? Yeah, done with handkerchief.
Yes, sir. Cloth experiment.
Yeah, right. So what we are studying, it's called classical mechanics. Okay, whatever we are studying, it is called as classical mechanics. Now there's again quantum mechanics. So in that, according to that, gravity or gravitation is basically a distortion in space-time continuum. Okay, and that involves lots of maths, not fluid mechanics. वो एक chapter है स्नेहा. ठीक है, fluid mechanics also comes under classical mechanics, right? Okay, thank you everyone. If you have any doubt, please ask me. Okay, I'm here. If you don't have doubt, you can leave. For today, I'll give you some problems, not that many problems. I just want you to pre-read. Okay, I just want you to pre-read. Okay, I'll give you some material. Please pre-read those materials. Okay, I'll upload in the same Google Classroom. Yes, quantum mechanics is of subatomic particle. Okay, okay. Bye everyone. Thank you. Thank you everyone.
Hello,
Yes,
sir.
I'll send DC Pandey as well as VM Sharma. Okay, I'll upload both. Okay, everyone.
Hello, sir.
Okay, bye everyone. See, I'll still request make your own notes. Okay, I'll still request make your own notes. Read the books, right? But make your notes.
Hello.
I can't hear you if anyone is speaking.